Okay, this is the 2018 VCE Methods Exam 1, Question 5. You might just be able to see the question at the top of the page there. We've got a function, 1 over x minus 2 all squared, and we want the rule and domain of the inverse function, f minus 1. So I always figure it helps to visualize what's going on. I like visual approaches to solving problems. Helps me to understand what the hell I'm trying to look for. So I'm going to do a quick sketch of this particular function so that we might be able to think about what the inverse could look like. Hopefully you recognize that that is a truncus. So if I do just a really quick sketch, quick and nasty, not going to sort of worry too much about particular values and so forth. I just want to get a sense of what it looks like because that'll help with, or at least it helps me with the inverse function. So I know that it's a truncus. It's got asymptotes at x equals 2. Hopefully you can see from the nature of the function itself. So there's an asymptote at x equals 2. There's an asymptote on the x-axis at y equals 0. And then the function itself would look like that, at least the full function. Of course, this one's got a restricted domain. The domain is from 2 to infinity. So basically I'm only really interested in this particular part of the function. Now, how does that help me? Well, to construct the, let's actually draw that again, but just with the function with its restricted domain. Again, asymptote at x equals 2, and basically I'm after the part of the truncus that is above, or to the right-hand side along the x-axis to the vertical asymptote. Now, if or when I'm trying to figure out an inverse function, I need to remember that the inverse function is a reflection of the function about the line y equals x. So if I was to draw the line y equals x, or at least this is my sketch of the line y equals x. Remember, I'm not worrying too much about particular values, but that would be, so here's my line. I want to reflect this function about that line. So what's going to happen is the asymptotes that are part of that function, they're also going to reflect. So I'm going to get a new asymptote. Actually, let me just see if I can, sorry, I should have planned this a bit earlier. Let me just see if I can sort of take this in a different direction, different color. So my new reflected x equals 2 asymptote will become y equals 2. My x equals 0 asymptote will become y equals 0. And I'm going to then expect that my, at least the positive part of my truncus, or the upper part of my truncus, will reflect to be something like that. So I'm looking for a function or a rule for a function for that particular red one. Okay? So, again, don't have to do that, but I think it's just nice to sort of visualize what's going on. So I want to get the inverse function. So I'm going to let y equal my original function, y equals 1 on x minus 2 squared. Then I'm basically just going to swap the x's and the y's. That's the reflection about the y equals x line done algebraically. So I'm just swapping my x and y terms. Then I'm just going to do a bit of algebraic manipulation to get this in y terms, to get y the subject of this. So I'm going to multiply everything by y minus 2 squared. I'm going to then divide by x. I'm going to do that all in one go. So it's going to end up looking like this. Hopefully that makes sense. Then I'm going to take the square root of both sides just to get the y minus 2. Square root of 1 is just 1, so it's really just the 1 on the square root of x. And finally, I'll just add 2 to both sides, and so I'll get 1 on root x. Y equals 1 on root x plus 2. Now, that's the rule for my inverse function, so let's write it in function form. That's what they actually asked me to do in the question. So that's the function. Now, what's the domain? Well, the easiest way to figure that out is to look back at the original, or to look back at the graph that I sort of, vaguely sketched, and hopefully you can see that that is going to exist for any x values above 0. So the domain is going to be from 0, not including 0, that's an asymptote, but from above 0 to infinity, or if you like, all positive real numbers. And that's question 5.